Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA Semester 2 Routing and Switching Essentials, which is Chapter 3 VLANs. This is Section 3.3 VLAN Security and Design. Upon completion of this section, you should be able to troubleshoot VLAN and trunk configuration in switch network, configure security features to mitigate attacks in a VLAN segmented environment, and explain security best practices for VLAN segmented environment. IP addressing issues with VLAN. It is common practice to associate a VLAN with an IP network. Because different IP networks only communicate through a router, all devices within a VLAN must be part of the same IP network to communicate. In the figure that displays, a PC1 cannot communicate to the server. So this PC here cannot talk to the server here. Have a look at what do you think is the problem. If you pause the video, have a look at the problem. Well, if you did, great. If you didn't pause it, you find it now because it has a wrong IP address. So if you look at the PC1, has an IP address 172.172.10. So here, this 172.172. So this part is wrong, yeah. So it's on a different network. So 17 here. So obviously it's not going to be able to communicate. If all IP addresses mismatches have been solved, but the devices still cannot connect, check the VLAN exists in the switch. Make sure that the VLAN is still there. Show VLAN brief, see if VLAN is there. If VLAN, for example, somebody maybe have deleted, no VLAN, whatever, 20 and so on. So no connection among devices in the same VLAN. Is a port in the correct VLAN. So show VLAN, show MAC address table, have a look at the port. Show VLAN brief, for example, will display what port is on the what VLAN. If it's not, assign the port to the correct VLAN, for example, switchboard access VLAN 20. If it's in the correct VLAN, you have assigned it, you put in the correct VLAN and still not able to communicate, check the VLAN present on the VLAN database. So for example, show VLANs, show VLAN brief, show interface switchboard. If it's not, then you need to create a VLAN in the database. So for example, if somebody has deleted VLAN 10 and the port should be on VLAN 10, you have to go and create VLAN 10. If you've done all this, try to verify the connectivity among the devices on the same VLAN. Introduction to Troubleshooting Trunks. Troubleshooting Trunks, native VLAN on local and a pure ports match. Show interface trunk. Here in the end, it will show the port, the native VLAN, so it has to match. If it's not, you need to go and change it. Switchboard, trunk, native VLAN, whatever that it is. If it is, trunk modes on and local and peer ports compatible. So show interface trunk, making sure that for example, we even have a same trunking protocol. Statically configure ports on both devices to be trunked, for example. So switchboard mode trunk, and there should be operational trunk. Common problems with trunks. Trunking issues are usually associated with incorrect configuration. The most common type of trunking configuration errors are native VLAN mismatches. I told you all the switches, they have to have the same native VLAN. Doesn't have to be one, can be any, but as long as there is the same. Trunk mode mismatches. So for example, if one side says switchboard mode trunk and the other one says switchboard mode access, that doesn't work. Allowed VLANs on trunk. If a trunk problem is detected, the best practice guidelines recommended to troubleshoot is the order shown above. Double tagging attacks takes advantage of the way hardware on most switches de-encapsulate 802.1q tags. Most switches perform only one level of 802.1q de-encapsulation, allowing an attacker to embed a second unauthorized attack header in the frame. After removing the first and legit 802.1q header, the switch forwards the frame to the VLAN specified in unauthorized 802.1q header. Private VLANs. The private VLAN edge feature, also known as protected ports, ensure that there is no exchange of unicast, broadcast, or multicast traffic between protected ports on the switch. Local VLANs only. A protected port only exchanges traffic with unprotected ports. A protected port does not exchange traffic with another protected port. So for example, private VLANs is, imagine this is the ISP and it's got a customer. Here, customer A and customer B. You can have a same VLAN for customer A and same VLAN for customer B because they don't talk to each other. There is a private VLANs.
Mainly ISPs use this. VLAN design guidelines: move all ports from VLAN 1 and assign them to non-in-use VLAN, unused VLAN. Shut down all unused switch ports. Separate management and user data traffic. Change the management VLAN to VLAN other than VLAN 1. The same goes to the native VLAN. Ensure the only devices in the management VLAN can connect to the switch. The switch should only accept SSH connections. And disable auto negotiation on trunk ports. Do not use the auto or desirable switch port modes. Thank you very much for watching this section 3.3 VLAN security and design. Please have a look at other videos and don't forget to subscribe. This has been Asir Krasinshi. Bye bye.